All right, hello everybody. Welcome to the sixth lesson. So in this lesson, I was going to go over some like advanced statistical tests and concepts and all of this other wonderfulness that is kind of a precursor to creating your own type of model and doing more quantitative based stuff. However, we're gonna take a little side swipe around that and get into a little bit more fun stuff first and sort of start applying some things you've already learned. And yeah, it's gonna hopefully be fun, teach you how to look for some relationships and how to start data mining. So the topics we're going to cover today is I'm going to teach you how to learn to look for those statistical relationships within the data. I'm going to teach you how to learn how to data mine from the data that's available. And I'm going to teach you to learn how to begin to develop a model within the confines of Excel. We will get into Pinescript for modeling as well in later tutorials. Today we're just going to keep it at the Excel level. It's a little bit easier, a little bit more straightforward. So let's get into it. The first thing we need to do is get a set of data. We have SPY here on the daily, and I think this is good for us to use. Now, before we go ahead and export this into Excel, we need to figure out what are we most interested in. We can export the data as is, but it's not going to give us a lot, right? It's not going to give us a lot of information. It's not going to give us anything to build on or anything to look for relationships. We need some context to this data. So let's go ahead and pick some indicators. Let's do MFI. Let's do stochastics. Let's do, what else could we do? Let's do RSI. And let's do Z-score. Now make sure that the parameters of all of these are what you want. So this is 14, this is 14, this is 500. I do not want 500. I actually want to keep it consistent with everything else, and I want it at 14. So we're going to flip that over to 14, and perhaps we could add in volume. Okay. So now that we have all of that, we're going to go ahead and export this so we can do some analysis. We're going to export chart data. ISO time, export. All right, so now that we have our data exported, what we're going to do is we're going to just filter out what we don't want because this exports a lot of data. We do not want the volume MA. Do we want it? Maybe we'll leave that just in case. We have MFI, our stochastics, our stochastic MA, RSI MA. We don't care about these Bollinger Bands. Don't care about any of this. And we don't care about the border. Okay. So now that we have our data, the first thing that we can do is we can look to see if there's any relationship between these variables as is. So to do that, we can go to our data tab, our data analysis, our correlation, and we can highlight all of these labels in first row. We're going to do it on a new worksheet just to keep this sheet clean, and then we're going to do OK. And you should already have data analysis added to Excel from the last tutorial. If not, you can do that through File, Options, and Excel add-ins. All right, so here are our relationships. So this is how we're going to look for statistically significant relationships, just by doing a simple correlation assessment. Now, there's other tests that we're going to get into, like t-tests and tests of stationarity, all of this wonderful stuff. But for now, we're just going to use a simple correlation. So we're going to look for anything. So in general terms, anything that's statistically significant is said to have a correlation of 0.5 or higher, or negative 0.5 or lower. For me, with stocks, I've lowered the bar to +3 and -3 just because it's really hard to find technicals or anything that have a really significant relationship on price. So keep that in mind when we're looking through this data. So we see that RSI has a positive 3.33 correlation relationship with open, so that's great. But what's even better is the RSI-based MA has a far more statistically significant effect on open. So we're going to just highlight these as potentially great candidates to include for our data analysis. The other relationships we have here are stochastics, not great, not really a great relationship between any of this. 0.2 is admirable, but it's just not, it's not 0.3 or higher. But the stochastic moving average has a 0.3 relationship on the close price, so we're going to highlight that. Volume doesn't really seem to do much other than have an effect on the technicals themselves, but we don't really care about the technical values in terms of volume. We really just care about being able to predict price movement, and that we don't really want to predict the technical value. So nothing overly fantastic here. Volume itself doesn't really have any effect on price. It's all below 0.3. The only thing it's really affecting is the volume itself, right? So not great. And we can take a look at MFI. We have a substantial relationship between MFI and stochastics. Again, doesn't really help us. We do not care about predicting technicals. We need to predict price and price movement. So this is pretty much the extent of what we're getting. The technicals explain themselves, but they don't really explain the prices that well, right? That's essentially what we're getting from this, right? There's high correlation between the technical values in amongst themselves, but when you apply these technicals to price, they lose all kind of predictive value, right? Which is why a lot of people, especially quant traders, are really against technicals, because they're just not statistically significant. They don't explain a lot of the variance we see within the stock price. But we can't throw in the towel yet. So what we can do is we can do something called data mining. And data mining is just extracting data from data sets you already have. You're looking within the data to find other data that relates to what you're looking at. So what can we pull, what can we mine out of all of this data? Well, the most obvious thing is we can mine red versus green candle. So we can create a column or a variable called red versus green. Now, because we're going to be doing a correlation assessment on this, we need to tell Excel to represent a red and green candle in a numeric value. So let's use 1 for green and 2 for red. So we're going to use the command if close is greater than open, 1 for green candle, otherwise 2 for red candle. Okay. So we're going to drag that down. Now, a lot of traders, a lot of people care more about the red versus green candle to indicate whether the sentiment is bullish or bearish. However, I think that this is the greatest fallacy in trading, even caring about red or green candles, because it doesn't mean anything. Why it doesn't mean anything is if we open up SPY, and we'll just clean this chart up. We'll get rid of all of this. If we look at some daily candles, I will show you why we should stop caring about red versus green candles. So right here we have a green candle. Okay. Now you would think that that is bullish, but no, the money to be made on this day was actually by shorting it. If we take a look, this moved negative 2.39 cents to the downside, okay? It only moved 61 cents to the upside. The money to be made this day was shorting. Now, if we look at this next candle, for example, it's a red candle, but we moved from open to high $3.97. From open to low, we moved 40 cents. So what we really care about is the move from open to high and open to low. it's really difficult when you're trading to get in midday and get a trade like this, right? So if we suspected that it was going to be a red day after all of this bullishness, if we shorted it, it's going to be, it doesn't always turn out well because usually we don't get these kind of reversals. This isn't a normal candle we see. So it's better to know the move as our open price as a reference point, right? Because generally we're taking our trades in the morning. We're doing it when the market opens. We're doing our assessment and we're making our trades. So we really want to use open price as our anchoring point and see what we can expect. A higher move from open to high or a higher move from open to low. So we can mine that data out of this by creating two variables, open to high and open to low. And we just calculate it exactly as it sounds. So we use the sum function. Open to high is going to be high minus open. Open to low is going to be open minus low. We want to just keep it as a positive value. So then we're going to drag this down so we have these variables available, okay? Now let's see if this changes any of our assessments, if this increases any of the data correlations that we have present. So we're going to do another correlation assessment. We're going to highlight all of this, and we're going to pay particular attention to the open to high and red versus green assessment. So here's our data. Let's just open this up so we can see what we're interested in finding is any statistical significance in this area. So just scanning through the variables, we can see RSI explains a lot of the open to low. RSI's MA explains a lot of the open to high. Z-score explains really great the open to low. And red versus green has obviously an effect on open to high and open to low. We don't really care about that. Okay, so we've identified some statistically significant relationships. Now, unfortunately, correlation is a very basic assessment. It doesn't really tell us what that relationship is, except that it's a negative relationship, which means as one increases, the other decreases, and vice versa. So as the RSI-based MA increases, our open to high decreases. And as our RSI increases, our open to low decreases, and vice versa. So that's the extent of what a correlation can tell us. It can't tell us where to look for more information. We kind of got to figure that out as our own, just using logical deduction. Okay. Now, it's great that we found relationships, but this isn't all that predictive. Why? Because we are using the same day, right? This is all same day. So it's going to be, it's not going to work, right? Because we're not going to get these readings until the day ends, and by that point it's over. So what we have to do is we have to lag the value. So we can either lag open to high, which is probably going to be the easiest. So let's just do high lag, low lag, red versus green lag. So this is the previous day, this would be the current day, right? So what we care about are the technicals from this day placed on the open to high from this day, right? So what we can do is we can lag it up. So open to high is going to lag up, and low lag is going to be lagged up, and that is going to be lagged up, right? Because we're using these to predict next day. So then we can drag this down. Now let's rerun the correlation assessment just with this, just to keep it clean. So we're going to go to data, data analysis, correlation, we're just going to highlight the stuff we care about just to keep it a little bit clean. And let's take a look at what our results show. So what we want to pay attention to is our lagged values. So a lot of that statistical significance actually carries over, right? So we can see that the high lag, it is influenced by MFI, by the stochastics, by the stochastic moving average, by RSI. A lot of this is carrying over, right? So this is great. It means that we can use these previous day values to get a feel for what tomorrow may look like. So really all of these, let's just try to find three or higher. So the 3 or higher seems to be the RSI. The RSI MA in terms of the high lag. And I believe that is it. Okay. So RSI and RSI based MA seem to have quite a significant relationship. So we can start recording some of this data down. If you have like a notebook or something, you can start, you know, when I do these little experiments, I have like a manual book that I'm writing the correlation and what it's correlated to, just to keep track of things. You can do what works for you, but you're going to be looking at a lot of numbers when you're doing this and a lot of relationships, and you're going to have to try to remember like, oh, where was that relationship again? So it kind of helps if you have like a notebook just to like write this stuff down that you want to come back to. So we do want to come back to the RSI and the RSI MA because these seem to have very substantial relationships to the high and low. In terms of the red versus green, absolutely nothing, but it is a useless metric anyway, so it's fine. Now let's flip back over and let's see if we can mine anything else. Could you think of something else that we can mine from this data? Well, we could mine the average. So we can use the average command and calculate the average of all prices. And then we can lag the average. So this average and its effect on this day, or we can lag it up because, no, we can't. Sorry, we have to lag it down. So we're gonna lag the average. So yesterday on tomorrow, tomorrow on the next day, etc., etc., etc. So we're gonna lag it down. And let's see if there is any statistically significant relationship. We're going to select all of the data and let's take a look. We are interested in the average values. Okay, so we have our correlation table and we can see what's going on. We're going to just pay particular attention to this average lag, and you see already we're just like shooting out the statistical significance here. Boom, 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 boom. What is this? This is RSI, RSI, RSI based MA. Oh, this is a really significant relationship, actually. Okay. All right. Okay, so now that we have all of this, we can start looking for where these relationships, or how these relationships, it's better to say, influence our data and how we can maybe start to use them to make predictions. Now to do that, what we can do is we can create a pivot table with some of this data outlined, right? So let's start with our open position over the average. So let's use our if command. If this open is greater than our previous day average, then we're going to be opening above average. Otherwise, open below average. And we can use string variables here, words, because we're not going to put this through any correlation assessment. We've already done that. So we have that. Now let's see sentiment. We can do if we want to use our current day open to high is greater than open to low. We're going to say bullish, otherwise it is bearish. And I don't really care about the red versus green candle, but we can put that in if equals 1 green candle, else red candle. All right, so let's take a look at what the pivot table shows us. So if we go to insert pivot table, we're going to open it on a new worksheet just to keep everything clean. So now we have our pivot table. So let's just take a look at open position. Now let's say we open above the previous day average. How often does that contribute to a bullish versus bearish sentiment? So it's pretty 50-50, right? 181 bullish, 182 bearish, so, or 177 bearish, sorry. So not great. What about opening below? Again, 50-50. What about our red versus green candle? Like really 50-50. And what about opening above? That's a little bit better. Let's take a look at that in percent. Value, show value as, percent of grand total, 56. So it's still pretty, not significant. Now, just as a side note, get used to this because when you're doing data analysis, it all works out to being 50-50. Stocks are incredibly, incredibly adamant about sticking to the 50-50 rule. It's really hard to crack stocks because they're 50-50. No matter how much analysis I've done, I always come back to 50-50. And that's why a lot of quant firms and quant traders take more market neutral positions instead of speculating, because it's really just too 50-50 all of the time. And yeah, you're going to see that when you do your analysis. But there are ways to tilt the odds in your favor, even when you're working with 50-50 data. We just have to be very specific about it. And we're going to get into that next. So we can see here that there's just, it's just not going to work, right? So we're going to get rid of this. But we still have all of this other data to work with, right? So we can take a look at where we found some statistically significant information, and actually it was with our RSI. So let's go back to our data here. Let's do a RSI info. We want the max, the average, and the min. So we're going to use equals max, RSI, equals average, RSI, equals min. So these are our reference points. So the RSI has been as low as 24, as high as 76, and the average is 52. Now we can make conditions based on that. So if the RSI falls between like 76 and 73, we can do all of that. But the easiest way to do it, and when you're creating a model, the best way to do it is try to get as precisely a value as we can. So if the RSI closed the previous day at 67.67, we want to find precisely that range, right? We want to look at 67 and any decimal point in between. So let's see if that changes the results of our assessment. Let's see if we start seeing greater than 50-50 odds if we start isolating for more precise measurements. So we're going to create an RSI here. So we're going to use the if and function because we're going to input two conditions into this conditional statement. And what those conditions are going to be is, let's say we want to look for an RSI that was like this. So if RSI, actually no, let's do exactly neutral. No, No, it's not, because you're going to get 50-50. Let's do 64, okay? So if RSI is greater than or equal to 64, comma, that comma is our and, RSI is less than or equal to 65, then we're going to say true. Otherwise, it's going to be false. So let's throw this down. And remember, we're using our lagged RSI, right? So this is K2, we're on K3. So we're using yesterday's RSI to predict tomorrow's variables. So be careful when you're sorting this stuff that you're using the right lag to use predictive values. You don't want to use the same day technicals because we don't have those same day technicals until the day closes. And by that point, it's useless, right? Because the thing did what it was going to do. So yeah, just be careful that you're including the right data. So now we're going to go ahead and highlight this, and we're going to go insert. We're going to reinsert a pivot table. Now what we can do is we can do our RSI for all of the times it fell between 24 and 25. I think is within 24. What was the sentiment? All right, so now we're getting somewhere. These are a little bit better odds, right? So 64% was bearish, 35% was bullish. All right, now we're making progress here. Now we're getting some useful information. Why don't we go ahead and try to add another condition like open below average? It changes. When we open below average and the RSI was in that range, 75% of the time it was bullish. And that's really all the variables we created, but you can add in as many as you want, right? So if RSI was this and MFI was that, what does that mean? You know, let's add one more. Let's add a MFI. So MFI, if and, oh, we need some context. I'm not an MFI trader, so max, average, min, max 90, average 50, min 12. So let's say MFI was 88. So if and we want to use that lagged MFI value is greater than or equal to 88 and MFI is less than or equal to 89, then we're going to say it's true, otherwise it's false. Now we can go ahead and do the same thing. We're going to import RSI and MFI. So RSI we're going to say is true because we want to isolate for those. Aha! So there's no similar times MFI was that value when RSI was that value. So what do? Well, we can't combine them. So what we could do is we could expand our search parameters for MFI. So the issue was that our data set was far too small. It was only including years from 2021. So I went back and I just pulled over the data we're working with into a longer data set dated back to 1993. Okay. So using this, I've copied over our variables, and let's pick our RSI. Let's do 58 to 59, and let's carry that down. And let's do an MFI of 64 to 65. And let's carry that down. Now let's hope that this works. Let's highlight this, insert, pivot table, new. Let's import our RSI and MFI. So true, true. And now let's see how that affects our sentiment. Okay, so with those relatively identical readings, the likelihood is that the next day is going to be a bearish day. It's 66% of days following technicals. Those technicals ended bearish. Okay. So we can trust these results a little bit more because of that statistical significance. Remember, we tested the statistical significance. We saw that RSI and MFI had a somewhat statistically significant effect on our high to open and our open to low. So we can trust these results to be pretty reliable. Now, that's not to say that they're going to be 100% reliable, but they're going to give us an idea of what to expect. And, you know, a lot of really experienced traders can actually determine sentiment by looking at RSI or technicals, stuff like that. This is just more of a rigorous way to do it. Now, with all of that said and done, can we use Pinescript to do the same thing? And the answer is yes. We've been building up to doing stuff like I've showed you in Excel with those little tutorials that we've been doing along the way. So you do have the knowledge you need to create a Pinescript version of what we did in Excel. That way you can run your assessments right from Pinescript. And I know I said we would do it in a later video. I'm going to just show you the bare bones of how you can get started and running with doing this in Pinescript. You've already learned the fundamental keys in the previous videos. If you haven't watched those, go back because it's going to cover all of the fundamental keys like importing technicals and doing all of that. The only thing I haven't shown you yet, which I'm going to show you now, is how to tell Pinescript to count and what you're looking at. So if we open up a Pinescript window, we're going to go to open, new indicator. Let's just call this my probability. Okay. So if you remember, we need to import technicals. Now we can do, because we want to import technicals on the daily time frame. If you remember when I taught you how to create a function to call something, we're going to quickly create a function, the same function we created in previous videos, the security request function. So we're going to do security request. It's going to be input request security sim info.ticker_id. We'll pull the information from the current ticker you're on. Our time frame is going to be on the daily. Our expression is going to be our input, and we're going to close it off. All right. So now we're going to do RSI equals security request ta.rsi close and 14. Our MFI is going to be security request ta.mfi. This is H1CL or something. Let's just use close. Close and 14. All right. So now we have our technicals. We need to be able to input our technicals. So let's create a variable input, RSI input equals input float. Remember, it's a float value because it's not going to be a perfectly round integer. So we'll default it to 20. RSI input. We're going to do MFI input equals input float. 20 is our default MFI input. Okay. We need tolerance. Input float. 5 is the tolerance I usually put on my momentum-based stuff. So tolerance level, we'll use that. And that is it. So now we have our RSI, our MFI. What do we need? Well, we need to know whether it is going to be bullish or bearish, right? Oh, and actually we need to backdate this. So when we want to say pull the data from the previous day, all we do is we open up these little box, this little box here, and we put 1. So it's going to pull the RSI from the previous day. We're going to do the same for MFI. So now we need to know our high to open and our open to low, right? Because that's what we did in Excel. Just like in Excel, we can do it here. All we're going to do is we're going to use, again, the security request function. We'll create a variable called high to open, same as we did in Excel. Security request, high minus open. Okay. Open to low, security request, open minus low. And there we go. So the fundamentals are there. We have just created the meat of our assessments. Now what we have to do is we have to tell Pinescript what we want it to do with this information. And we want it to calculate and accumulate the variables to tell us a rough estimate of what the probability is going to be. So to do that, what we're going to do is we're going to do, first of all, we need to create some kind of output display, right? We can't actually plot this, so we need it to give us a visual representation of our data. So what we're going to do is we're going to create a table. So we're going to do var table. This is prompting Pinescript to say, okay, we want to create a table. We're going to call the table data, table.new. Now we can pick a position for it. So let's use position. Let's use position bottom center. How many columns and how many rows do we want? Well, we'll do 5 and 5. What color do we want it? Let's just do color black. Very simple table, okay? So now that we've created our table, we need to tell Pinescript to look for days that have similar RSI and MFIs to our input range. And how we can do that is by creating a true or false statement. And a true and false statement in coding and in Excel is called a Boolean, all right? So we're gonna label this bool, and we're going to call it similar day. So a similar day would be our RSI is greater than or equal to our RSI input minus our tolerance level, and our RSI is less than or equal to our RSI input plus our tolerance level, and MFI input is greater than or equal to, MFI is greater than or equal to our MFI input minus our tolerance, and MFI is less than or equal to MFI input plus our tolerance. Okay. So let's go with that. How we get Pinescript to look back is by using a function called a loop. And we need to add in an integer up here. So input, we're going to call this look back, input integer. Let's do 1500 days. We'll call it look back period. So to declare a loop, a basic counting loop, we need to confirm that the day has closed. And to confirm that the day has closed is if bar state is last. And I think I did this wrong. If bar state is last. Okay. So once we've clarified that this is the last bar, we can count from this last bar on. We're going to go for I equals 0 to look back, which just means that we are going to, from day 0 to day 1500 is what we're going to look back. Okay. And the reason we're putting this as our look back instead of just doing to 1500 is because then we can modify the settings. If we're not getting any results, we can look back a bit further. If we're getting too many results, we can look back a bit more recent. So this just allows us to have some customizability in our look back, okay? We need to create some counter variables. So we need to declare them as counter variables, which means we have to use integer, int. Let's do within range C for within range count equals 0. So for I equals 0 to look back, if similar day is true, right? So if similar day, you don't need to do is true. Instead of doing that, you can just do similar day I. And what that means is that for each similar day within this loop, when it is true, it's going to count it. So for I equals 0 to look back, if similar day I, which is just essentially saying if similar day is true in our look back history, then we want to add a number to our within range count. So to tell it to add a number, we're going to just say plus equals 1. And so for each similar day that comes up, it is going to count for us, okay? So let's just export those results. So we have our table here. We just need to throw this data in our table. So how we can do that is create a new cell. The table ID is data. Column 1, row 1, text is going to be, we're going to call it number of similar days. We're going to do a space. Then we're going to add. We're going to use a function called string to string. Now this is just going to plot the variable contained within this variable. So we want to put to string within range count. Color, we'll keep the color as black, and our text color will keep as color white. Okay. So let's add this to the chart. So we can see number of similar days is 7. Let's just open this up bigger. So we want to make sure that we're on the daily because we are looking back on the daily. Now let's change, let's say our RSI is 54 and our MFI is 64. Our tolerance is 5. There's 73 similar days. We can narrow that down by reducing our tolerance to 2. See what that does. There's 8 similar days, right? So we can play around with it, and it's just like that, okay? But we need to know when we pass. So we're going to create another Boolean called bullish day. And a bullish day is going to be high to open is greater than open to low. And we're going to create a bearish day when open to low is less than high to open. Okay? Does that make sense? No, I'm like legit asking. I don't know if this is right. Sorry, no, it's wrong. Open to low is greater than high to open. Okay. Now we need to add 2 counters. So we're going to do bullish day, bearish day. Okay. And we follow the same rules here. So if bullish day, we're going to do bullish day plus equals 1. If bearish day, bearish day plus equals 1. Okay. So now we just need to copy this because we need to put these into our table. So we'll do table. We're going to put this in row 2 and row 3. Number of bullish days and number of bearish days. So bullish day, bearish day. Okay. Now let's update that on the chart. Uh-oh, there's a problem. What's the problem? Pinescript cannot determine the referencing length of the series. You're going to get this error quite a lot when you're doing these like probability stuff. The easiest fix to it is go up into your indicator title, comma, max bars back equals 5,000. And it will resolve the problem. There you go. Oh my god, something's wrong. Number of bullish days is 746. Ooh. Oh. My bad. My bad. I forgot to clarify that we're only looking at this when it's a similar day. So what we have to do is end similar day. End similar day. All right, let's try that. There we go. So you see it's 50-50. I don't know what our MFI or RSI is for today to check for tomorrow, but you get the point, right? So we can do a little window here. So let's create current RSI equals TA RSI close 14. And current MFI equals security request TA MFI close and 14. So let's create one more column. Let's color this blue just so we know that it's not showing us our probability stuff. And we're going to say current RSI. We're going to leave this as this. We're going to put RSI here. Oh, no. Current RSI. Then we're going to add, we're going to leave a little space, current MFI plus string to string, current MFI. Now let's update that on the chart. Okay, so now that we have our current daily RSI and MFI, we can put that in. So let's just do 59 and 45. And let's see. So number of bullish days is 11 and number of bearish days is 5 and total number of similar days is 16. So there you go. You've just created a basic look back probability model on Pinescript and in Excel. So that is going to conclude this video. It's already pretty lengthy, but hopefully you learned something from it and can apply it. In the next lesson, we're going to get back into those boring statistical tests. But just wanted to do this because this was more fun stuff. So there you go, everybody. Thanks for watching. Take care.